All right, today we're going to be running calibration and checkout on an MESE008 actuator. This is an 800 inch-pound actuator, 120 volt open closed jog. Has a manual override hand wheel built into it and mechanical stops. It is mounted to a 2-inch 3-piece stainless ball valve. And we're going to go ahead and check the calibration and set the cam travel for both directions and also the auxiliary switches. So this, as I said, is a 120 volt on-off unit. We have a 120 volt test box here, and we're going to go through the procedure on what needs to be done to calibrate this unit properly. So the unit has a 4-cam stack. 2 cams are for the travel of the actuator. The bottom 2 are the actuator travel, and the top 2 are for your auxiliary switches. The green cams are used for calibrating the counterclockwise open direction, and the 2 red cams are used for calibrating the clockwise closed direction. So this is an epicyclic type gear train, and as in all electrics, you don't want to run the motor and stall it into mechanical stops. So even though this actuator leaves the MaxxAir facility fully calibrated when it's mounted to a valve as a valve actuator assembly, it's fully calibrated for 0 and 90 degree operation. But if you have to make any changes to the cam settings for whatever the reason, if you want to limit the travel, if you want to increase the travel, whatever you need to do, the first thing you want to do on these type of gear trains is get the mechanical stops away, get them backed out so that any changes you make in the cams electrically are not going to allow the motor to drive the gear train in either direction into the mechanical stops. So I'm going to use a 17 millimeter wrench. I'm going to loosen the jam nut, and I'm going to back this mechanical stop out 3 or 4 turns. And it really doesn't matter how many, as long as you get it moved away at least 3 turns. And I'll do the same thing on the other one. Just loosen up the jam nut, back out the mechanical stop, and therefore there's no way to get the actuator motor to drive the gear train into those mechanical stops. We'll go ahead and reset those after we get all the electrical travel adjustments made. So powering up the test box, it's a 120 volt test box pre-wired for the operation of the actuator as well as the auxiliary switches. So we're monitoring all the position of the switches, both the travel switches as well as the auxiliary switches in this case. So the first thing we're going to do is, right now the actuator is in about a 50% mid position travel, and if I looked at the ball valve through the bore of the valve, I could see that the valve is actually about 50% open. So what I want to do is I'm going to set the clockwise closed position first. So I've got power on the box, and I'm going to just drive the actuator clockwise in the clockwise direction and let it move, drive the cams until it stops. So I can see with the auxiliary switch tripped and the pilot switch tripped that the actuator has stopped traveling electrically. The auxiliary switches and the end of travel cams have actually actuated against the limit switch, and we have a full stop electrically of the valve. So when I take a look at the valve looking down in the bore, I can see that the valve is not fully closed. So what I'm going to do is I'm going to turn the power off. I'm going to run this manually, and I'm going to turn the hand wheel clockwise to drive the valve to the full closed position. And that looks about right. So now I've got the valve in the full closed position, and the actuator is where it needs to end up when we're setting the cams. So at this point, I'm going to go ahead and set the travel cam. in looking at the wiring diagram, you can see that the number 2 and the number 4 are the red cams. Those are our clockwise positioning cams. Number 2 is end of travel. Number 4 is the auxiliary switch. So to stop the end of travel, I'm going to adjust the number 2 cam. And keep in mind that the indicator is turning clockwise to close the valve. So I want to adjust the end of travel cam moving in a clockwise direction. So I'll move this off cam. You can hear the switch clicking. So now I'm off cam, and I'm going to snug this up slightly and then slowly rotate it until I hear the first click. Right there. So now, and I snug it up just slightly, and that tells me that the end of travel cam is now in the correct position. I'll go ahead and turn the actuator test box on. We're going to drive it out off cam a little bit, and then back and see where it stops. So now the actuator has stopped electrically with the end of travel cam, the clockwise end of travel cam, and I'm going to check the valve bore, and yes, indeed, it is in the correct closed position. Now I'm going to go ahead and check and adjust the end of travel cam for the auxiliary switch. And again, I'm going to move this off cam. I'm going to snug it up a little bit. I'm going to watch this indicator here to tell me when this is tripping. So you can see that that's where it's made. And I want to go just a little bit further to the left and lock it in. Now I've got those both set. I'm going to drive it out and then in. And what we should see is the clockwise drive direction should illuminate. Then the auxiliary switch should come on, and then the pilot switch should tell us that the end of travel has occurred electrically. So we'll drive it closed. We should see 1, 2, 3. Perfect. Check the bore on the valve. The valve is exactly where it's supposed to be. The indicator is showing closed. The actuator has stopped electrically in travel, and the auxiliary switch is timing correctly for the clockwise position. So now I have calibrated the clockwise position on the actuator. So in looking at how this thing is running, keep in mind, we're going in a clockwise direction to close. We are in the full close position. That means this mechanical stop is the one that also controls the clockwise movement of the actuator. So since we stopped the actuator electrically with the switches, now I can go in and lock down and touch off on the mechanical boss inside the actuator. And there's where it bottoms out. And that actually prevents the hand wheel from going any further clockwise. You cannot, when the stop is here, you can't drive the hand wheel any further. It's a hard stop. We are outside of the cams, so there's no chance the motor is going to drive into that. To prevent any interference through maybe cam dwell angles or anything like that, you always, once you touch off here, you back this off 3/4 of a turn, lock this down, and that gives us the mechanical stop is now set. So if I take this actuator and I move it off cam, you'll see that the actuator immediately starts driving again to the full closed position. We're backing out manually, drive it full closed. And if it's set properly, you should be able to get about 1 turn out of the hand wheel before it locks. There you go. So now we have the electrical set for the travel, we've got the electrical set for the auxiliary switch, and we have the mechanical set for the mechanical stop on the hand wheel on the valve. We're going to follow the same procedure for the full open position counterclockwise. So we're going to drive counterclockwise. We're watching the indicator run counterclockwise. And the actuator has stopped electrically. I don't care about the auxiliary switch at this point. It's stopped electrically, and I'm going to look at the bore on the valve and see where it ends up. and I can see that the valve is not open fully. You can see where the valve isn't set. So now I'm going to rotate the hand wheel counterclockwise until I can watch the valve open full bore. That looks pretty good right there. So now I've got it set using the hand wheel. I've got the valve set in the full open position. Now I can adjust the cams to make it work electrically. So I'm going to use, looking at the wiring diagram, I can see the number 1 and the number 3 cams are green. Those are our counterclockwise open cams. So number 1 and number 3. So the number 1 cam, keep in mind now, this indicator now turns counterclockwise to open. So I want to make sure that I adjust the cam by moving it in a counterclockwise direction to set it properly. So I'm going to loosen it, spin it way left, snug it up tight slightly, and then just rotate it slowly to the right. Power it up and check it. I'm going to drive it off cam a little bit and then run it counterclockwise and see where it stops. I'm going to check the bore, and we're perfect. So the valve is now sitting in the right place. It has stopped electrically using the bottom green counterclockwise cam. And now I'm going to go ahead and set the auxiliary switch for the open position, counterclockwise open position, using the same thing. Move it off cam, watch the auxiliary switch, and I can see when it's adjusted properly. That handles it exactly. So you can see. So now what I'm going to do is I'm going to snug this up just a little bit until I see that indicator come on. And a little bit further. Lock it down, and we're good. So now I'm going to go ahead and drive it off cam. If it's set properly, we should see the sequence that we're driving counterclockwise, the auxiliary switch comes on, and then the pilot comes on. So we're driving 1, 2, 3. Now it's set properly. End of travel cam is set properly, and the auxiliary switch cam is set properly. So the last thing we got to do on this unit now is to adjust the counterclockwise open mechanical stop. It stopped electrically, so it's not going to travel any further under power. I'm going to go ahead and bring this into the mechanical gear train stop inside the housing. It's locked on there. Back it out 3/4 of a turn and lock this in position. And we are set. I'm going to go ahead and drive this off cam. Come back, let it stop. 1, 2, 3. And then I should be able to run this in the open direction about a turn. Half a turn. That means we got it set. So the mechanical stop is outside of the limits of the electrical travel of the actuator. A word on the set screw adjustments on the cam. There's virtually no pressure on the cams other than the roller wheel. You don't have to really tighten down hard on those cams. If you're twisting your 2.5 millimeter set screw trying to loosen or tighten those cams, you're using way too much force, and it just causes problems for small calibration adjustments down the road. So that's your adjustments for the mechanical stops, and for the electrical travel, we'll go ahead and run the actuator to a full closed position, which is the standard default position for shipping. The indicator is running clockwise, looking from above. The valve is closing, checking the valve bore, and I can see that the valve is closing. And there's all our indication. Everything is set, and that's the end of the calibration for that unit. Everything checks out. We've gone through all the electrical stops and the mechanical stops. It's good to go. Final word, don't lick the wires.